Yesterday you learned how to write orbital notations to show the location of electrons around the nucleus of an atom. Today you're going to do something very similar. We're going to be creating electron configurations, and that is just another method for showing the structure of the electrons in an atom. This method, though, will not have us drawing the individual orbitals with the arrows representing the electrons. But we're going to start the same way. The first step will be finding our element on our periodic table, and you need to have the one that we have the sublevels labeled on, all the S's, P's, things like that. So we'll look up aluminum on our table, and aluminum is over here on the right. It's in the 3p sublevel, and it's the very first element there in that sublevel. So we're going to start at the very beginning. We're going to start here with 1s, and we're going to be listing our sublevels, but this time we're not going to write the orbitals above it. We're not going to draw anything. We're just going to write the name of it. So we're going to have 1s. And we'll just put a little note over here that since it's 13, we're going to end up with 13 electrons at the end, and it's the first element in the 3p sublevel. So we're listing them. Once we get through 1s, we look at the next row. We have 2s and 2p. And we'll just write that after it. And we keep going. The third row, we'll have 3s and 3p. And since that's where aluminum is, we'll stop there. And then we have one last step we need to do, and we can actually kind of do this next step as we're working through the problems. But what we're going to do is we're going to write a number for the number of electrons that are found in each one of those sublevels. So remember, when we have an s sublevel, we would just draw one orbital, and there would be 2 electrons that could fit there. So every time you have an s in your electron configuration, we're going to put a little 2 up at the top, kind of like you're squaring it. So every time you write one of those 2's, or every time you write an S, you'll have a small 2 up at the top after it. That's telling you that there are 2 electrons there. Every time we had P, remember we would draw 3 orbitals, and if you fill in your electrons to those, we had a total of 6 electrons. So every time there's P, we're going to put a little 6. Just like we were squaring it, only we'll put a 6 instead. Now, just like with orbital notation, we would wait and you do that very last sublevel at the end, and the number of electrons we put would go along with its position in that sublevel. Aluminum is this first element in 3p. So that means that we don't need all 6 electrons in this last sublevel. We only need one of them. So the only part that will end up not being a 2 for an S or a 6 for a P would be that very last one. Okay, so let's try again with 10. We worked that one yesterday with orbital notation all the way over here, number 50. So we're going to start at the beginning, and we're going to list our sublevels. We already have 1s through 3p listed on the other one, so we got 1s, and we can go ahead and put the 2. There's 2 electrons there. The second row was 2s2 and 2p6. 2 electrons in the S, 6 in the P. We move on to the third row, and this time we have to go past 3p, so we'll go ahead and fill it up with 6 electrons, and then we'll get down to our fourth row. So our fourth row starts with 4s, can hold 2 electrons. We get to 3d. Remember, there are 10 elements going across. There's an electron in each, so you have a total of 10 electrons in 3d. And we'll just keep on going across until we get to 5p. So we have 4s2, 3d10, and if you want to have that up at the top, whenever we have d, we have 5 of those orbitals. If we put 2 electrons in each, that's where that 10 comes from. If we finish up that fourth row, we start with 4s, 3d, 4p. Then you go on to the fifth row. 5s, 4d, and 5p. And that is where 10 was located, was in that 5p sublevel. So that's where we're going to stop. And if we look at that 5p sublevel, where is 10? It is the second element. So that means that you're going to have a total of 2 electrons. We could hold up to 6, but that would be 1, 2, 3, 4, 5, 6. Whatever number we write in that last spot goes along with that element within the sublevel. So we're going to put a 2. The last one here, radium, we are going to get down to the F sublevel. So if you want to add up here at the top, we've got 1, 2, 3, 4, 5, 6, 7 of those orbitals if it's an F sublevel. So if each one holds 2 electrons, and we'll end up with a total of 14. So outside of that very last sublevel you write, if it's an S, it'll always be 2, P6, D10, F14. Just the number of orbitals times 2. So when we look up radium on our periodic table, radium is all the way down here. So we're going to go through the similar process. We got all the way over here to 5p on the last one. So we'll continue past 5p. We'll get 6s. Remember, right here in this gap is where these 2 rows fit in. So after 6s, we go to 4f, back up to 5d, 6p, 7s, and that's where radium is. So we have to start at the very beginning and list all of them through 7s. And if it's helpful to you, you can kind of mark it to where it's a row at a time. So we've got 1s with 2 electrons, so that's your first row. Then you have 2s and 2p, that's your second row. You've got 3s and 3p. When you get to the fourth row is where that overlapping starts to occur. So you have 4s2, 3d10, 4p6. Fifth row has that same pattern, 5s2, 4d10, 5p6. And you don't have to have these little dividers that I'm making. If it's helpful for you to do it that way, include them. Otherwise, you can just run them all together in a long line. When you get to the sixth row, remember we kind of pointed out that you have to jump down to the bottom row to get that 4F, and it holds up to 14 electrons. You go back in the exact same place, and you go to 5D, and then 6P. So that was that sixth row. And then we said 7S was where radium was, so we'll stop there. And it was the second element. Francium was first. We just put a 1 if it was francium, but this one's radium, so we'll put a 2. You will not, in textbooks or anything like that, see these lines. It would just all be together in a long line. So if you would prefer not to have those there, that is fine. Okay, so this is electron configuration. Very similar to our orbital notation. We just are not drawing the orbitals with the electrons in them. We're just listing them and putting a number to say how many electrons are there. Now, a way you can double check your work, we didn't write it down, but 10 was number 50. That means it's going to have 50 electrons. If you take all of these exponents that you wrote, the small numbers that are up top, and you add those together, that will give you the same number. So if you wanted to double check, you would just add all of these numbers up, and you could either work it out on paper or in your head, and that should add up to equal the atomic number for that element. So just a way to double check your work. Now, even though this is shorter than our orbital notation, there's an even shorter way that we can write down this information. And that's going to be our abbreviated electron configuration. It's going to show the structure of the electrons, but we'll get to substitute a part of it with a noble gas. And think about where the noble gases are in the periodic table. They are in group 18, that very last group on the periodic table. So you're looking for one of those in that very last column, and I kind of think of it like Price is Right. You want to get closest to it without going over. So we want to get closest to this element without going past that element on the table. So for example, strontium, when we look up strontium, it's going to be number 38. It's over here. So we're looking for our noble gases, something in this column over here on the right-hand side, and we want the noble gas that's closest to number 38 without going above that number. So we've got 36 right here, and we've got 54. 54 goes over. It goes beyond strontium on the table. So that means that krypton will be our noble gas closest to it. So we're going to put Kr in brackets, and then we'll start after that. That took care of everything from 1s all the way through 4p. So it took care of everything across here, and you don't have to list any of those sublevels. Just by writing Kr, we took care of it. So that means you start after Kr. We're going to start with 5s. And since strontium is in 5s, that's all I have to write. It's the second element, so that means that I'm going to put 5s2. If we wanted rubidium instead, it would have just been 5s1. So that's the abbreviated, sometimes it's called the rare gas configuration. So just a shorter way to get the same information across. When we look at iodine, okay, iodine is over here on the right, number 53. And you might be tempted to go with xenon because it's right next to it. But we cannot go beyond the number 53. So that means 54 is too high. We can't use it. We are stuck still using krypton. It's the closest to iodine without going beyond it on the table. So we're going to have Kr in brackets again. We'll have 5s, and then we'll keep going. So after 5s, we'll have 4d, and then 5p. And that's where we'll stop because that's where iodine is in 5p. So to repeat that, we're going to put Kr in brackets. We have 5s, and it's full. 4d, it's full. And then iodine, when we look at its location, count how many over it is in that 5p sublevel. It's the fifth one over. So we're going to say there's 5 electrons there. For this last one here, tantalum. Tantalum's going to be right here, number 73. So the noble gas closest to 73, without going past that number, is going to be 54, xenon. So we're done with those. We're looking at xenon now. And then we just start after xenon. So we'll have our 6s, 4f, and 5d is where tantalum is. So we'll stop when we get to 5d. And it's the 1, 2, 3, third element over. So we're going to put our xenon in brackets. That takes care of the first 5 rows on the table. So 6s, we jump down to 4f, back up to 5d, and we said it was the third element over. So that's the abbreviated configuration. We could also just look at the very last position and just find an element. So if it's in 3d5, we go and we find 3d. So I've got a lot of colors going on here. We've got 3d right here, and we want 3d5, so 1, 2, 3, 4. Looky there, that's the fifth one over, so that's manganese. So we fill in Mn. 4p3, we go to 4p, the fourth row. P block's over here on the right. We've got 1, 2, 3. Arsenic. (5F10). So we go to 5F down at the bottom. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Californium. So we can fill in CF. Okay. Last one, 2s1. 2s, right up here. First element, lithium. On the back of yesterday's assignment, you have a little bit of everything here. The first few will be problems like the top, where you write out the entire configuration. You have 4 of those. The next part is like the last thing we did, just find which element matches that position. And then the last section, you get to use the abbreviated configuration, where you use the noble gas closest to it, and it's a much shorter answer that you'll come up with.